Well, hello, algebra. This is a quick summary of a whole bunch of different concepts related to quadratic equations. Now, we have already done a little bit of work with quadratics so far, and we did basic, simple, what are called um, binomial quadratic functions, and we had something like 3x squared plus 1 equals 7. So, plus 1. So we had some term that was second order, meaning x to the second power, whatever variable it is to the second power. And that's what makes it quadratic. It's a binomial because if I simplify this down to a form that equals 0, so if I subtract 7 from both sides, 3x squared minus 6 equals 0, then you see I have two terms, and that's what the bi and binomial stands for. And we were able to solve these. So in this case, you would solve this by taking and subtracting 1 from both sides. So you get 3x squared equals 6. 3 side x squared equals 2. And so x equals square root of 2, which then you could plug into your calculator if you needed to. Just from a little naming standpoint, a cool mathematical way, instead of saying square root of 2, you say radical 2, because that is the name for that symbol, is the radical symbol. So you're going to hear me refer to that some in the video. So when I say radical, it means whatever follows those words is going to be under the square root sign. So we've done binomials, but what we want to move on now to are quadratic polynomials. So poly refers to multiple terms, and specifically we're going to look at what's called the standard form quadratic trinomial, or we can just say a quadratic equation. And the standard form quadratic equation is ax squared plus bx plus c equals 0. So a, b, and c are coefficients, they're numbers for our variable x. And so we see three terms of x. We have a squared term, we have a to the first power term, x by itself, then we have just a coefficient term with no power of x whatsoever. Technically, I guess we could say it's x to the 0th power, which equals 1, but then I'm just getting nerdy. So this is the standard form. So really, to work with quadratic equations, you need to rearrange things somehow to be in standard form. So if I have something that looks like this, 3x squared equals 2x plus 21, that obviously is not in this format. For it to be in standard form, it has to be equal to 0, and we have to have simplified terms, x squared, then x, then the constant in that order. Well, this is a matter of just rearranging the equation. So I'm going to choose to keep 3x over on this side, and I'm going to go ahead and subtract my 21. Oops, I'm still in a race. Subtract my 21 from both sides. So I get 3x squared minus 21 equals 2x. And then this is something that's a little unusual. We haven't done this before. I'm going to subtract 2x from both sides. And you say, well, gee, if I subtract 2x from 2x, doesn't that leave me with nothing? That's correct. It leaves you with nothing. So 3x squared minus 2x minus 21 equals 0. So that is a quadratic equation in the form ax squared bx plus c. So a would equal 3, b would equal -2, and c equals -21. Notice that in standard form, these are all pluses. So if in your equation you see a minus, that means the coefficient there is a negative number. So the coefficient is -2, -21, and 3. So A equals 3, B equals -2, C equals -21. Another way that we can work with equations then is with what's called the quadratic formula. And so if I take my equation, 3x squared, copy it from one slide to the next, minus 2x minus 21. And one way that I can solve that, or if nothing else, one way that I can analyze this equation to figure out how I might be able to solve it is with what's called the quadratic formula. And this is going to look really scary, but just remember, we already know that A equals 3, B equals -2, C equals -21. So the quadratic formula is x equals -b plus or minus radical b squared minus 4ac, all of that over 2a. So it looks complicated, but in order to solve for x, all you do is go to your equation and you'd look for the values a, b, and c, and you just substitute them in. So in this case, it would be equals negative -2 plus or minus radical -2 squared minus 4 times 3 times -21, and all that over 2 times 3. And this is where we want to have our calculator because I don't want to do this by hand. And after I plug that into my calculator, I get this quantity under the radical, and I'm going to change to a different color here. This quantity under the radical equals 256. So all I've done right now is put that into my calculator. So -2 squared is 4, minus 4 times 3 times -21. And so notice this is minus, going to be minus a really big negative number. So that's how we end up with a positive number. So just the number under the radical is 256. This is an important number. 256 is what's known as the discriminant. The discriminant. And what it's important for you to know is whether or not your discriminant is positive or negative. So in this case, if I go on to solve this equation, I'm going to get, switch my color, I'd have negative, I'm going to go ahead and do -2, so +2 plus or minus the square root of 256 over 6. So I could go ahead and solve that and get an answer, and yay, we'd all be happy. But what if when I had done the math, it's blah, 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 negative b equals plus, excuse me, negative b plus or minus radical -221. What's the problem here? The problem is you can't take a square root of a negative number and get a real answer. So real numbers, the combination of the integers, the entire number line, rational, irrational numbers, the square root of a negative number is not part of the real number system. It becomes part of the imaginary number system, which are not imaginary numbers, they're just not real numbers. And you may remember from long ago, we talked about how the square root of -1 gets this little symbol I. So that's for algebra 2, can deal with the imaginary solutions. We're going to stick with just real solutions. But it is important to know that if your discriminant is positive, you have a real solution. And if your discriminant is negative, it's an imaginary solution. So sometimes when solving a quadratic equation, you will just find the discriminant just to know whether or not your solution is real or not. But we're going to focus on just equations that have real solutions for the purposes of our class. So you should be able to take an equation in standard form and plug your A, B, C values into the quadratic formula, negative b plus or minus b squared minus 4ac over 2a, and get values of x. That's one way to do it. And notice, as we would always expect, two answers. But the big difference is that whereas in a binomial, our solutions were, something like, if we say x squared equals 4, x equals plus or minus 2. So we had plus or minus a value. In polynomials, you're going to have two solutions, but they're not going to be the same number. So if you have, let's say this is 5, and this is square root of 4, and this is ends up being 6, you would have 5 plus 4 over 6, so 9 over 6, and you'd have 5 minus 4 over 6, 1 over 6. You'd get two solutions, but those solutions would not be the same number. It would be two different values that you get out of the quadratic formula. Another way that we work with quadratics is what's called in their factored form, and we've taken a look at this a little bit before to introduce it. Let's take, for example, another equation in standard form, x squared minus 3x plus 2 equals 0. So we're in standard form. We know that a equals 1, b equals negative 3, c equals 2. We could plug this into the quadratic formula and get our values for x. But another way that you can solve or work with a quadratic is by factoring it. And when you factor a quadratic, you end up producing terms that only have x, not x squared. So if the factored form of a quadratic equation is going to be x, terms of x, and in this case, it's 1x, so it's just going to be x on both sides there. We'll look at more complicated ones later. And then I happen to know that the factored form of this equation is x minus 1, x minus 2. And you say, well, where does that come from? Well, where this comes from is, if I work this backwards, there's something called FOIL. And FOIL stands for first, outer, inner, last. So my first terms are x and x. So I multiply x times x, which is x squared. So that's f. My second, or my outer terms, are x and negative 2. So if I multiply x times negative 2, I get negative 2x. My inner are negative 1 and x. So negative 1 times x is negative x. And then my last is negative 1 and negative 2. If I multiply those terms together, I get positive 2. So combine like terms, x squared minus 3x plus 2 equals 0. FOIL is pretty easy. Taking a factored form and getting it into a standard form is pretty easy. The other way, which we'll work on kind of separately from this, is how to actually factor the equation. There's a little, what I call the kite trick to doing factoring, where you can draw yourself a little kite and multiply, add symbols there. So I know that I need two numbers that will multiply So a number here that will multiply by each other and get to 2. So 1 times positive 2 is 2. But then I need those numbers to be able to add up to negative 3. So here's what we have to think about factors. What are factors of 2 that when added together will equal negative 3? Well, factors of 2 are 1 and 2 and negative 1 and negative 2. So 1 times 2 equals 2, negative 1 times negative 2 equals 2. And if you notice, if I add negative 1 and negative 2 together, I get negative 3. So the negative 1 becomes one term, and the negative 2 becomes the other term. Negative 1, negative 2. But we'll practice that a little bit more. Don't get overwhelmed with that right now. But these factored forms are kind of fun because once you factor it, there's no, huge deal of plugging things into your calculator. For anything to multiply and be 0, it has to multiply by 0. The only way you can take a number and make it equal to 0 is through multiplication is to multiply it by 0. So the solution to this equation is either when x minus 1 equals 0 or when x minus 2 equals 0. So x minus 1 equals 0 when x equals 1, and x minus 2 equals 0 when x equals 2. So our solutions to this are x equals 1 or x equals 2 are solutions to this through factoring. So you can see how if you can factor the equation pretty easily, then the solution's a whole lot easier than plugging into this big ugly thing. But they both work. So FOIL, big part of this. Not only knowing how to go from factored to standard using FOIL, but then also how to use our little diagram to go from standard form to factored. So FOIL, the little kite drawing, the quadratic formula, negative b plus or minus, I lost my radical, plus or minus b squared minus 4ac over 2a. That's important, standard form. And so what we remind ourselves with is we always get two solutions. When we have a simple binomial, those two solutions are going to be plus or minus some value. When we have our polynomial quadratic, we're going to get two solutions of two different values. And if the discriminant is positive, those two values will be real numbers. If it's not, they'll be imaginary numbers, and that puts us a little bit beyond the scope of our work right now. All right, we're going to dive into this. We'll take it one step at a time, but this is the grand overview of quadratics. Eventually, you get into loads of fun down the road when you graph these, and they graph as these cool curve-like functions called parabolas. But you know what? We only have 3 weeks left of class, so we probably won't get there, but hey, we'll have fun trying.